Greetings everyone and welcome to this new video on bootstrapping. The term bootstrapping originated from a phrase in use in the 18th and 19th century to pull oneself up by one's bootstraps. This phrase referred back then to mean an impossible task. Today, it refers more to the challenge of making something out of nothing, or a self-starting process that is supposed to continue or grow without external support. In statistics, bootstrapping is a robust estimation method to reduce bias. It is a data-based simulation method for statistical inference. Bootstrap methods are intended to simplify the calculation of inferences and produce them in an automatic way. To explain the process of bootstrapping in simple terms, imagine that we had sampled 20 data points. We now want to resample these 20 data points into another set of 20 points. When we perform bootstrapping, we randomly select a data point from the original dataset and add it to our new bootstrap dataset. We do this process 20 times so that we again have a sample set of 20 points. Now you may be wondering, how does this dataset differ from the original one if we take up the same measurements? The bootstrap dataset is different because any data point in an original dataset can be resampled any number of times. Hence, a data point from our original dataset can appear more than once in our new bootstrap dataset, and another data point from our original dataset may not appear at all in the new bootstrap dataset. This process of creating a bootstrap dataset can be repeated any number of times. Creating such datasets will help us to analyze the resampled or bootstrap datasets. For example, we can calculate the mean of all the bootstrap datasets and order them and calculate the limits within which 95% of them fall. We can thus use these values as estimates of the limits of the 95% confidence interval of the parameter under question, in this case, the mean. This result is known as the percentile bootstrap confidence interval. Similarly, we can also calculate the standard deviations from the parameter estimates from the bootstrap samples and use it as the standard error of the parameter estimates. In essence, when we perform bootstrapping, we are resampling our data to mimic the sampling process we have originally performed on our original dataset. Hence, we would get an idea of how our dataset would look like if we redid the experiment a bunch of times. Furthermore, bootstrapping helps us to reduce the assumptions required to validate the analyses. An important point to remember is that because bootstrapping is based on taking random samples from the data we've collected, the estimates we get will be slightly different every time. However, this is nothing to worry about. That's it for this video. Thanks for watching, and I'll see you in the next video where we explore bootstrapping with the help of an example.